Thank you. You can all hear me? All right.
Yep.
Then I'll start. Okay. The topic of the day is presented in the slide. It's about the land administration domain model and my experiments with converting that conceptual model to a certain implementation. And today I will tell you more about the details of that. The second slide is about me. Peter already started explaining. I work for COWI Denmark, which is an engineering company. And for them, I do work on international projects, land administration, a large part of it, but also urban planning. And my roles are presented on the slide. I'm a database and software designer, developer, IT architecture, IT solutions. It's a bit of a mix of all for clients and for clients mostly in Africa the last 10 years. Yeah, so I was 1 year ago, I was in Lesotho, which is in southern Africa, or it's actually landlocked inside South Africa. And because of Corona, I had to come back to the Netherlands, and I had a bit of time on my hands to do experiments with web application development, with 3D urban planning, three-dimensional urban planning, with spatial data collection with mobile devices. But I also did an experiment with the LADM, the Land Administration Domain Model, and GeoDjango. And as Peter mentioned, in 2008, I finished my Master of Science thesis or education on the topic of Land Administration Domain Model, Survey Package, and Model-Driven Architecture. Basically, this was about a semi-automatic implementation of a platform-independent model to a platform-specific model. In this case, the land administration domain model defined in Enterprise Architect, a modeling tool, and then have Enterprise Architect generate the Postgres database that will take care of instantiation of the model. Yeah, I should point out that in this presentation, I sort of assume a certain knowledge of land administration domain model. Otherwise, it will be quite boring. I guess you have to have some interest in it. I will not explain all the elements of the land administration domain model. That's all I'm trying to say. At the bottom, you will see. I don't know if you see my mouse moving, so I can. Yeah. So here you see a little progress bar, so you know when the end is near, and we can also. Take care of if I'm speaking too long, you can see where I am in the presentation and how much slides are still left. Okay, first, before I get to the experiment and the results, first an introduction of a number of elements in the IT architecture that I use for the experiments, namely Object-Relational Mapping, Django, GeoDjango, Postgres, and Docker. Those elements have been part of the IT architecture. And I made a few slides just to introduce them. An object-relational mapper plays a role in the conversion of conceptual classes into implementation objects. The advantage is that a developer talks to the application objects and doesn't necessarily need to know a lot about SQL statements and things like that. There are a number of candidates which are renowned, I would say, in terms of ORMs, but I chose Django and GeoDjango specifically for the GeoDjango part was interesting to me to experiment with ORM mappers. So that is this slide. Django is a web framework, so it's not just an ORM. It provides out of the box basically a web framework, an administration GUI, but also an ORM mapper, which was interesting for this experiment. And it also has GeoDjango, the capability of dealing with spatial data, with geometries. Yeah. Then, of course, there is a database, and yeah, I'm very familiar with Postgres. I used to work for Oracle, so I had like 20 years ago, I had Oracle glasses on. Oracle was the only thing that mattered. But yeah, some years back, 15 years back, I got introduced to Postgres, and basically all the work I'm doing now is based on this open source database. Obviously, the extension PostgreSQL for geometry is interesting, but there are a number of other extensions. I just listed a few. The one for 3D is interesting, but also the PG routing to do a network analysis, calculate the quickest and the shortest distance from point to point through a road network, for example. So PostgreSQL is, yeah, I think a very useful tool in land administration and urban planning, the projects that I do in those fields. Then we have Docker. To me, Docker is new. I didn't know it until a year ago, but it is really making life easy when you deploy your environments quickly. I see there are some people from Dutch Cadastre here. Dutch Cadastre is working with DevOps, with deploying environments quickly based on similar tools. I don't know if they work with Docker, but they work with containerization of applications. So Docker is also an element in the IT architecture of this experiment. Not necessary for the land administration domain model, but I just wanted to generate an IT architecture that can be the basis for a web application, for example. That was one of the side goals that I had. So to explain a little bit more about Docker, having said that I'm not an expert in it, but before Docker, or let's say 10, 15 years ago, virtualization was the main thing, which is presented in this picture. You see that a virtual machine always has an operating system, a copy of the whole operating system, and then all the applications are configured within that context, and then you have another one and another one. Docker is slightly different and more lean, I would say, less data. In Docker, you have one operating system and a number of containers. So in my case, the containers, there are 3 containers. There is one for the database. There is one for Django, which is sort of the application and the modeling, the model object. And there is a little web server, in this case, Nginx. And if you have a large user group that makes use of your application, you can duplicate those containers to do something about load balancing. That's the essence of Docker containers. And then words like Kubernetes come in, and DevOps and all that. That is where Docker plays a role. So that is the elements of the IT architecture. Now we get to the actual topic, which is land administration domain model in GeoDjango. Now, the land administration domain model consists of a number of packages. The administrative package with basic administration units or titles and rights, a party package with parties and links to actual persons or non-natural persons, and there is a spatial unit package with the geometry side of it. And in my experiment, I maintained that division. I tried to maintain it as much as possible, with only the exception of grouping the code lists into one section, because in my future application ideas, I wanted to maintain those code lists in one place. That is actually the reason for it. But other than that, I maintained the administrative, party, and spatial unit division that you can also see in the land administration domain model. I use a development environment, PyCharm, but there are others. But since Django, I haven't mentioned it, but Django is Python-based. This is a Python related development environment. So this is the the ID as it's called. And you can see here that the packages are represented here. And on this side, you see part of the model, the basic administration unit, which is a versioned object, and then the type and the name and the other attributes. I'll get to that. Okay. So the first example I wanted to show you is on the left side, a LADM class, which is the basic administrative unit or basic administration unit, which has a name and a type and a unique ID. And then here you have the Django class with a type and a name. And below that, the implementation in the database, which is generated by Django. So I only have to provide the name of the table, and then Django takes care of the rest. Yeah, so this is an example of attributes and the code list. So type is linking to a code list, which is implemented as a foreign key to another class. And in a database, you can see there is a table for that code list, prefixed with C because I wanted to have that in one place, the configuration place. Okay. Now, classes, attributes, code lists are sort of one-to-one with LADM. LADM and Django, you can make them almost the same. Many-to-many attributes are represented in this slide. So, for example, again, the BA unit has many-to-many associations to spatial unit, to itself, required relationships units, administrative sources, spatial sources, and parties. The way it's implemented in Django is, you can see here. So there is a definition spatial unit. It is a many-to-many field to the class spatial unit, which is defined elsewhere. And again, for all the other classes, you can see it's similar. What is there are two things important. One, or relevant to mention, is the many-to-many relationships or associations are implemented by tables, as you can see here. And what is also relevant is that I define the many-to-many relationship in the context of the BA unit, but Python afterwards give me the possibility to access it through spatial unit as well, that you can see here. So there is a field spatial units on BA unit, but there is also a field BA unit on the class spatial unit. So I define it in one side, but it gives me the bidirectional working with the classes and its attributes. Okay. So that's on classes and attributes and many-to-many associations. A quick slide in between is on Annex A of the Land Administration Domain Model, which talks about conformance. So you have a country implementation or some kind of implementation of the Land Administration Domain Model, and then Annex A is about assessing the level of conformance with the Land Administration Domain Model. Now, I have done a few of those assessments. One is of the SOLA software that FAO was building, the open source land administration software. And you usually see that the level of those land information systems are level 1 or partially level 2 on package level. But with this experiment, I was actually able to get to level 3, which is the most compatibility. Not that compatibility with the land administration, the model is a goal in itself, but if you want, you can implement the land administration domain model as is with Django. That was that's a conclusion of the work that I did. Yeah, that's on this one. Then another annex is Annex C, where there are examples, 36 of them, described of examples or instantiations of the model. So the first one is an example of a long lease, etc., etc. And Another conclusion of my experiment is that most, if not all of the examples I could implement, actually instantiate in this model that in this database that I generated with Django. So I made one slide, the next slide, with an example of one of those examples and instantiate it in the in Django or through Django, and I will take you through it. So this is example C5. It's a group party. It's John, Mary, and Joe. They are together in a group. They have the rights to a certain unit, which has a spatial representation here. Okay, so the first thing you do is you create a BA unit, and this is Python code. And what you can see it is using the classes of the model, not of the database implementation. So you simply say BA unit, the name is Smith's oven, the type is basic property unit, and then you have implemented that one. The next one is a spatial unit, which happens in a similar way. So Smith's place is defined as a object of class spatial unit with these characteristics. There is something with area. Then you link the spatial unit to the BA unit, also with a relatively simple Python line. Then you make the three parties, John, Mary, and Joe. They're all natural persons. And then you add those persons to a group party, and that happens with this line. So Smith oven users, party members, add John, Mary, and Joe. And then the last one is actually the instantiation of the right that this group has to the basic administration unit, which is this one. Yeah, I know this is programming, maybe too much detail, but it is to show to you that it's actually quite simple for a developer to use a model like this, and also to show you that the Python code uses the model, the classes and the attributes of the model, not of the database. Okay. So implementing all these examples was also very important for my understanding of the LADM. So I learned, even though I know the land administration domain model, I learned a thing or two about it by going through all these implementations. Then the second thing I forgot, I had another point, but it will come back to me. Anyway, so after defining some Python programming to implement the models, then it's time to generate the whole thing. That is the next slide. So what it first does is it creates the Docker containers, the database, the web server, and the Django Python environment with the model. It will transform the Django classes to the tables. It will load the code lists. It will also load all the Annex C examples that I programmed. And then the result will be a web app running with a database and ready to go. And on the right side, you see the actual, it's a movie. It's a screen grab of how that looks. And it takes 45 seconds to do all that. So you have nothing, and then 45 seconds to bring up all those containers and fill it with data. And I think it's almost finished. So those 45 seconds, yeah, it's finished now. So those 45 seconds that you just viewed. Okay. So another slide on examples of how to query. It's the same thing. It's Python programming or Python syntax. So here you have an example of querying all instances. All BA units would be BA unit objects all. Then you can count them. So all BA units count, 52 in this case. So I have loaded 52 records in this example. You can also get a BA unit by its primary key. I forgot to mention that Django has a default primary key on positive integers. So the OAD of the land administration domain model in all the classes is implemented as an integer, but you can change that if you don't like it to another type of primary key. So select by primary key, then count the spatial units within the BA unit of primary key 11, in this case 1, and then you can also query those spatial units. In this case, it's misplaced that we looked at before. So BA unit with primary key 11 has misplaced. And then this is by primary key, but you can also query by name, start with Gaia, for example, and then you will find 6 BA units, because there are quite some examples in LADM involving the Gaia place. And then if you print those units, you will see Gaia grazing grounds, lodge, social center, etc., etc. So this is an example of how to query the instances, again, using the model classes, not the PostgreSQL database objects. Okay, I also took the liberty of introducing some new classes, because I think they are needed. A gender type Codelist, currency type. We have parties, which are parties to the right, but I also felt the need of having a class person and non-natural person, which can be referred to from the party classes. I think in every implementation you will need something like that. So, and then if you have a non-natural person, it would be nice to have a non-natural person type. And I also did something on spatial unit group hierarchy, as presented here. What I didn't do, but that's something that has my interest, is introducing maybe classes for process type or process step type, but it depends on which kind of events or state-based modeling you're trying to implement. But there are a few Django packages that can help here. So that is future music. I haven't done anything with that. It's just an idea that I have. While I was implementing, I also found some implementation issues, which may be relevant to the next version of the land administration domain model. One thing you can't do in Django is you cannot have a type in a superclass that is inherited by a subclass with the same attribute. So for example, you have party type and group party type, those collide. It's not possible. A mortgage type and a restriction type, where mortgage is a subclass of restriction, that also collides. So somehow I had to work around those cases where this is happening. The second one, there are lots of question marks because I'm not so sure, but I felt that mortgage, which is now inherited from restriction, there are a number of issues with that. So mortgage is inherited from restriction, is inherited from the RRR class. So it gets all the time specification, share, and all the other attributes from those restriction and RRR classes. And I felt that maybe that was, I think the word is too much. So I'm questioning whether mortgage is a subclass of restriction or some other kind of solution for that continued inheritance of the superclasses is needed. But there are question marks, I'm not so sure. But what I did is I implemented mortgage as a class, not as a, without the inheritance from restriction. Okay, the last bullet is about the share check attribute. Somewhere in the land administration domain model, the ISO standard, it is defined that the share on the RRR class must be specified unless this is meaningless for the specific type of that RRR. So right now, share check is implemented as an attribute of the RRR, and I think it should be implemented as an attribute of the right type. And this is what I did. So that's a question that I think that needs some attention, because the modeling in the class is sort of in conflict with another text that is somewhere else in the same domain model. There is some conflict there. So I had to make a choice between one or the other, which is share check here or share check in the right type. And I chose for the latter one, for the last one. Okay, maybe it's too much detail, but there are, when you implement, you get to things like this. You have to make choices, and some of them I think should at least be addressed in making the new version of land administration domain model. So that is this, but also the previous slide on other classes. Okay, so what is the end result? On the left side, you see the numbers of classes and code lists, and on the right side you see the implementation in tables. And obviously, if you're going to implement many-to-many associations as a table, you will get a little bit more tables. But really, it's of no concern, because you're working with the classes on the model side. So whatever Postgres or Django and Postgres do on the database side, it doesn't really. It's of no relevance directly when you work with the model. Okay, some examples. As I said, Django comes with a web application framework. One of the elements is Django administration. So all the classes can already be maintained through a web interface. So an example here is group party types, the code list for group party, of the type of group party. And here you see the list also coming from the land administration domain model. And when you implement it and you find another group party type, you could add it here and it can be used. You can also, I also made an example of a web application dealing with the geometry side of it. So this is an example of spatial unit group and how it would be visualized with regard to the geometry. This is actually running live. I have a little playground for myself, GVB Jan van Bennekom GIS, and it's there if you want to see it, but just to see how it operates. GVB GIS is mine, and I only use it to do my experiments with Django and 3D and things like that. I also work a lot with QGIS desktop, and I made sure that I can also access it through that interface. I haven't tested ArcGIS, which is another tool that we use here and there, but I'm sure you can make it work. So in this case, you see point, boundary face string, and boundary face as classes that are used in QGIS. Okay. So that is about the first part of the experiment. Now, back in 2008, we also had an interest in constraints of the model. The constraints are defined in the model in OCL, object constraint language, but you still have to implement them. 10 years ago, or more than 10 years ago, that was an issue, the implementation of constraints, but also now I did some experiments with it. And I want to take you through that in a few last slides. I don't know where we are with the time. No, it's okay. There are basically two elements or two groups. You have constraints that are implemented in hard in the database, so there is no way of storing data that is not following the integrity that the constraints envision. For example, an attribute constraint null or not null, that will be implemented in the database, and it's simply not possible to have a null attribute or column which is defined as not null. So those are stored and implemented in the database, and there is no way around it. So examples are attribute constraints, but also tuple constraints, which concern the one or more attributes of the same instance, the same record. Those can be implemented in the database. A tuple constraint, for example, where the share is greater than 0, that is how it's done in the Python Django language. So that's a bit of syntax to get used to, but once you know it's the name of the attribute and then greater than or equal, GTE, that's the way it happens in Django Python, and then you can just start to read it. So this check constraint is tells you that the share is greater than or equal to 0, or it is less than 1, because I want the share to be within 0 and 1, as an example. A database constraint would also be unique together. So group and party should be unique in group party members. So you cannot have a group with the same party as 2 members. That's actually what it says. And ordering of lists is not a constraint, but useful to have, so you present your data always in the same ordering. But it should not be on this slide, actually. Okay, the next slide is about, we're now moving into the constraints that are not implemented in the database, but somehow can be checked and tested. So I made a slide with 3 examples. The first one would be a BA unit must have at least 1 write attached to it. Now, if you have a foreign key from write to BA unit, you're still able to have a BA unit without writes. So you need to check that. So the way that is done in this experiment or this example is simply by putting somewhere in the model the code that the BA unit .rr, the writes count is greater or equal than 1. So it's not checked in the database, but you can check it in your modeling and your application code. Another example is a group party must have 2 or more members. It's sort of the same. You get self total member shares. That's the wrong one. This is actually the next example. Let me give you another one. So self party members count is larger than 2. And this one belongs to the third one. The sum of group member shares must be 1. So the total member shares is 1. So this is an example of relatively simple constraint definitions in the model to take care of this one and this one and this one. There are a few constraints that are more complex, which require a bit of coding, but you can still, with relatively few codes, can get away with it. So, for example, this one is the sum of shares for a type of write, if the share should be checked, should be equal to 1. That's sort of, it makes sense, but this is what you need to implement it. So first you list all the write types that are involved in a basic administration unit. Then you select the writes of that type, and then if the share check is required, you calculate if the aggregate sum is not equal to 1, and then it would result in a failure. Okay. So this is an example of something that requires a bit more, but once you get the hang of it, it's easy to implement these constraints. Okay, it brings me to the last slide, or my conclusions. So I think it's clear to me, and hopefully now also to you, that with this setup with Django, it's possible to sort of 100 or maybe 98 or 99% generate the land administration model as is into a Django PostgreSQL setup. In terms of country implementations, you will of course need changes, but then those changed definitions can also be 100% automatically generated. I also looked into 3D. Now I know that Postgres is perfectly capable of storing and working with 3D information, but Django has an issue there. It only has support for 3D polygons, let's say, faces. It doesn't have support for solids, so the whole 3D definition of an object. So that is an issue if 3D is and sometimes I come across in my work in working with 3D, then I would not choose this solution or find some way around it. It's possible, the third point, it's possible to have a high level of conformance or compatibility with the land administration domain model. In this setup, it's really easy to change and then regenerate the whole thing. And then if you change another attribute or some relationship between two classes which you have not seen before, you just add it and then regenerate the whole thing, and it still works. So it's really easy. The trial and error, the iterative development of implementing the model in the land administration, the model in the Postgres database, is quite easy to do. As I said, there are some improvements I think that should be considered for a next version. And Django has a web framework included, but I think I covered that. So all in all, I think, yeah, this is the conclusion of my experiment, and I intend to continue with it, to do more experiments, maybe look into the 3D element of it. But that's, I think, concludes my presentation, and I don't know if you have any questions, but I'll be happy to to answer any.
Jan, thank you very much. A little applause. I do it from my side.
All right.
Yeah, I think your presentation could not have been better timed with the revision of LADM ongoing. Okay, for those who were not in the beginning here, Abdullah Alatas is ill, so he cannot give his presentation. So we have now time for discussion for those who want to stay as long as you want. But really, hey, your presentation is super well timed with the revision of LADM and also the need for implementations of say, standards specified at the conceptual level. I have many questions, but I will first give the floor to the other persons in the audience. Please open your microphone if you have a question. Yeah, Peter?
Jan, thank you for your presentation. It's very useful, I think. My name is Peter Aukes. I'm from Cadastre. So I recognize some of the things, and I can confirm we work with Docker a lot. One of the things I have you prepared a lot in advance, I think. Before you can run the script, you said it is 45 seconds and you have all. The preparation before you can do this, have you done that in a script, or can you more tell about the preparations?
Yeah, well, obviously part of the preparation is getting to know Postgres, Django, and the web server and Nginx. But I mean, the way I learned to work with this is also following other examples. So how it usually works is there are people who share their code and share their things on GitHub, some kind of version control thing. So if you know how to install Django on your machine, it could either be Windows or Ubuntu, Linux kind of setup. If you know how to do that, it is as simple as cloning some GitHub repository with all the code and the settings, and then say Docker run or something like that. It doesn't mean you understand how to make the changes and all that, but it's really easy once you know how to use Docker containers. It's really easy to deploy it. So if I have some other computers here, if I just want to quickly test something, I go there, I download all the stuff, and I run it just to see if it works on that one, on a Windows machine or a Linux machine. So it's it's a bunch of text files saying load the Postgres database from as a container, load the Django setup as a container, load the web server as a container, and that's it. Of course, after that, if you want to tweak it, you need a bit more knowledge. But for example, yesterday I was installing a GeoNode server, which is a spatial data infrastructure. It works the same way. So they have some repository that is available for me to use, and then I can just run that container, and it sort of works. There are always some issues, but so it's scripted.
I had the same question in mind as Peter. So it really looks like too good to be true. So much automation, and also in the object-relational mapping. Who does generate this mapping? Is it automatically, or do you write this code yourself, the scripting? Or
maybe I can share. I can share maybe the development environment just to see to show you how it looks.
Because there are really nice facilities. So I also saw that association classes were supported in an elegant way in one of your examples.
I mean, because I put it all in my presentation, not having to switch between the development environment and all that, but I can start it up and see if I can.
No, you can just tell me. I will believe you. What you you don't have to see it.
But no, what you do is you take the land administration domain model, and it has a class, and you define it as text. So you have to type the text, and then you generate it. So can you see this new, do you see this environment now?
Of a window. Yeah, now it's
yes, now yes.
Okay, so this is the class BA unit. So what I had to do is to type this in a model.
Okay, so you wrote it. You wrote it by yourself.
Yeah,
okay.
So I needed to take the descriptions of the land administration domain model, a PDF, and put it.
So yeah, actually you describe the whole UML model here by yourself in this language, and then continue. Okay.
Yes.
A bit like interlist. It reminds you of
exactly the same, Peter. Exactly the same.
Yeah. But I mean the land administration. Sorry.
No, go on. I'm sorry.
The land administration domain model to me comes as a PDF. Well, I had other definitions, but I took the PDF. So one manual step I had to do is to put it here in what is called models of the administrative package. So if you open this one, you see models, and then that's this file. We can also go to the models of the package.
Clear. So you did not use the EAP file.
No.
Neither XML or XMI from enterprise.
Encoding,
No.
They couldn't work. Okay.
Maybe there are ways to have your model. Actually, I think that's counter the Django philosophy. No, in Django you define the model as this, and you make your changes here. So if there is a new attribute, I add it to this list. If there is a new check, I add it to this list, and then it will generate it. So the whole generation part is fully automatic. It comes from here. It takes this as input.
I must say it does look a bit more, say, modern compared to interlist. Interlist is perhaps a bit old-fashioned, but the way you work.
Yeah.
I don't know, so I can't comment. But it's text. It's text. It's a text file, and it has the model, and this is this is where I make my changes and then regenerate the whole model from scratch, and then Go ahead.
Actually, you translate the conceptual model into a Python script for.
This is also a conceptual model, but in the definition of Django.
In the definition of Django. Okay. Yeah.
So this is.
But you transform it. Yeah.
So I don't see this model that we are looking at right now as something different than LADM, other than in a Django Python context.
Yeah,
like context, yeah.
Maybe it could be automated, theoretically.
Or
Yeah.
the other,
oh, no, actually, sorry to interrupt, because that brings me. I mean, in 2008, what I did is I had the LADM in Enterprise Architect, and I took the tools that are available to you in Enterprise Architect to generate a database. You could also take the same tools to generate this model. I think that's possible. So to generate the text files, because as you can see here, this is just a text file somewhere on my file system. So I could generate models.py. You see this, right? Yeah, I could generate this file from Enterprise Architect if that's what you want. That's possible. That's definitely possible.
It could have saved you typing.
No, I think the most
in interlist, it's kind of copying in another language.
That's what it is. Yeah. But also, I think more of my time went into thinking about the land administration, the model, and things like that. It's not, the typing is not a big issue.
Okay. When you generate the model, because you see you have to add something, and you have data in your database, what does that mean?
If I would introduce a new attribute here for group party, that's what, and if it would be a nullable field, then it will just work.
Okay, so you do not have to export and regenerate the database and then import your data again.
No, no. If you have an existing database, that will probably be the case. I think, that one I don't. I think I know where you're coming from. But if you have an existing application and then you change something, there are ways of generating only. Not regenerating the Postgres database which actually holds the data, but I haven't experimented with that. But there are different situations where it will not work. So if you define a mandatory column, there are other things you need to do first. Yeah.
Thank you.
Cannot do magic.
No, I think maybe it's too much detail, Peter. But I think a step could be to add that column in the database and fill it with data as you want. So you don't really touch your implemented database. Then go to the model to do the same, to have the model attribute. And then while generating, it will see, oh, I have this column, but I already have it, so it's fine. Okay. It will work like that. I'm pretty sure.
Other questions?
Yeah, I have a question. Jan, thank you very much. I am interested in how you look at the responsibilities on the data. So if you have your environment on the web and then you have multiple institutions, how would you incorporate some of the constraints that are in the responsibilities to the data into your model?
Yeah, I think I understand the question, but I have not been dealing with that. I think it's possible to define authorizations and security on certain classes, but that's not been a thought I had when I was doing this experiment. I do know that, and I think Grit Lemon also knows that this is what you encounter in all the countries where there are different responsibilities for data. Who is this custodian? Who is the source? Who is the maintainer, and all that. But I did not consider that topic in this experiment.
Yeah, no, I understand that. But let's say, let me rephrase then the question. Would you think that if that was to be the case, you can also automate the definition of those relationships between data sets and actors, and consider that in the transformation when you generate the Docker configuration and everything? Or do they have to be independently every time you instantiate your containers?
Yeah, I think it's possible, but it's
okay.
I'm not sure.
Okay.
Definitely not sure.
I have a second question, if I may.
Mm-hmm.
Suppose, you know, again, from countries where people are stubborn, so you have two agencies and they do both instantiate your LADM model in their agencies with their own databases. Would you perhaps also be able to combine those instantiations with a wrapper so that they can communicate with each other without having to separate themselves from the Django environment where the models are constructed?
No, I think that it would work with classes or some kind of association between classes, the same class in different institutions or something like that. But
okay. I mean, I found the whole thing interesting, but of course, sometimes it's also interesting what needs to happen next. I mean, this is.
I need to push the limits.
Push it a little bit further.
Yeah.
The last question, if I may, is on services. So how does it work when external agents want to operate? I mean, it's in Django, so it is a web environment already, but what will be the mechanism for an external application to consume those objects and present some data on an infrastructure or something?
I think you would then expose certain parts of your model through the same web server with an API or a service-oriented architecture kind of thing to allow them to do that. Yeah.
No, but again, I know that it is possible, but conceptually, can I conceive that, you know, when I create my class and I model it, there is also an exposure of that class into the outside world, so that I do not have to, when I create my containers and I create my instantiation of the LADM, then I have to start coding a service in front, or, you know. So would it also be possible to incorporate that into the model description that you have here in front of the screen?
Yeah, I think I don't know. I think I would need to deal with some examples, some specific examples to get some ideas, and I'm happy to, you know, after this or to do that. But
okay, yeah, right. Thanks.
All right.
Other questions? Jan, I had a question about the query you showed in Python, and you showed also the answers. What does it mean? What happens at that moment? Is then Python going to the database and execute the query, or does this Python instance swallowed all the data and did not communicate with the database to produce the answer? Yeah, these queries.
Sorry, this one. I think what happens, for example, the first one, get all the objects of a basic administration unit. It actually gets the data from the database. There is no the ORM, the Object-Relational Mapper, takes care of the communication.
Yeah. So you don't want to do this if you have a real national database.
No, you don't want to do this. No.
The second one you could do, the count. You could count, and that would not be expensive. It's just a query.
I think Django translates these requests, these Python commands, into SQL queries. Yeah. And if the SQL query to get all the objects is very expensive, I think there are ways of influencing that, so that it gets. There are terms like lazy loading, so it only loads the first 10 records or something like that. A count would be translated in a count SQL query, which usually is not performance sensitive. You know, select all the records in the 6 million table, you will still get in milliseconds. But select all the records in that table is another story. And then there are techniques like lazy loading and all that. This is actually an area of Django that I still need to explore more. But there are ways of.
But it sounds good.
Yeah.
This is what you want.
Peter, Django will always go to the database. It will not hold the instances on the memory unless it's absolutely necessary. So it will go down to the database and execute the SQL. But the SQL is created by Django's internal structure, so you don't have to worry about that.
Yeah. What I also, that is true. It creates SQL statements and then carries it out. what is also important to note is that it is also possible if you do know about SQL and you have your SQL queries that you're very happy with, there is a possibility of Django executing those ones, those custom queries that you like or that you need or something like that. So that's also possible, which I also find sometimes useful.
But you can, and you can also make them into a function if you think they are suitable. Then you can wrap them around, and others can also use it.
Execute SQL or SQL functions or things like that. It's possible. And this, by the way, is also because I'm interested in 3D information, and there are limitations in GeoDjango, obviously. But this making your own queries. SQL queries and functions in the database and then using them in Django would be a way around to deal with that incapability of Django towards 3D.
No, but there are also other Python packages that you can then incorporate into your Python infrastructure and operate them from within Django for those 3D elements.
A bit related is the issue about the constraints. You said, okay, some of the easy constraints are in the database, but the more tricky constraints with the if and the summing are in the Python. But okay, when is the constraint checked? Probably not on every insert or every update of the data.
It is checked on the application side. So whenever you want in the application to check it, you check it. But the constraint checks, the way I did it, and this is my implementation, the constraint checks are an attribute of the class. So I don't know if you can show you.
Yeah.
So you see group party has a group of constraints, LADM constraints. You see this, right? Yeah. Okay. Sometimes the switching of screens doesn't work, but okay. So there is a group of LADM constraints for the group party. It checks 2 party members. In this case, this is the actual code that is constructed, and the other one is the shares. I think I mentioned that in the presentation. And then here there is a sort of helper function on that. Let me see. And then in the versioned object, I sort of misused to have all the classes being able to call this constraint. So you can call an attribute, I forgot what it was, but I can quickly go there to show you, I think.
Yeah, version object is a good place to check the constraints, because if you make a new version,
because they all inherited from it.
Then is the moment when something happens. Yeah.
So I had to find a place, so that was it. But versioned object is here. Begin lifespan, end lifespan. Not all the attributes I know, but and then so there is a LADM constraints which is empty unless I do something at the class, which you just saw. But there is also check LADM constraints which will give passed or not passed or something like that. So it's empty if all the checks are okay, or it will tell you what is wrong. I think maybe I have an example here. This is the actual environment which I run this morning, and there is maybe some examples of those constraints being checked, I think. So here you have constraint validation is okay. So I'm using those checks to validate certain instances. So your question was, when do you check it? You check it application side when you want it in the application.
Yeah.
But it's important to realize that it's not a database constraint. That's just how it is. There is no way around it. I think to have all your constraints checked in the database, you either have a monster of a of development in your database, or you have to accept its application side but not database side. There is a trade-off for an optimization in between those goals, and I'm happy. I mean, the database is not accessible directly, so all the work happens through your application. So if in your application the constraints are all being checked and you make sure of that, there is really no argument to try to spend a lot of time implementing it in your database.
But also sometimes your reality does not fit to those constraints, and you still want to have some of this data. Still, it shows as invalid, but still stored in the database.
Yeah.
So you would like to be able to keep at the application level. You have separation of the elements, of course, you can easily demonstrate that, but you do not have to change your architecture to allow, let's say, inconsistent reality inside your database.
The examples in Annex C, if I remember correctly, the examples, the 36 examples, they have cases like that. So they implement a basic administration unit without a write sometimes.
Yeah.
So those basic administration units will show up in these checks.
Yeah.
Yeah, I think this is a nice generic issue that you have constraints where normally data should say adhere to, but in reality there are always exceptions. And sometimes I think the real constraint is, okay, the normal constraint, or you have to be in an exception list.
Yeah.
So that, and that's the total constraint, and that is true again. Maybe you are not fitting to the basic constraint, but then you have to be in the list.
Yeah.
Because then you have been improved, and then you are kind of validated or checked that you may exist. And then so it's the difference between the soft and the hard constraints a little bit. Okay, many interesting discussions. Are there more questions?
Yeah.
May I? Oh, okay, great, sorry.
No, Eftigia, please.
Thank you, great. Thank you, Jan, very much for the presentation. It's really interesting, and I think it's really on time with the revision of LADM. I would like to ask a very generic question. So if you zoom out to the technical implementation of LADM, where would you put this solution? So you do have the conceptual model in UML, and you would like to achieve, of course, a technical implementation. Where would you put this solution? And for example, Peter before mentioned Interlis, which is a language, it's a standard that enables the communication between land administration systems. And while trying to achieve implementation by using Interlis, we try to do exactly the same. So translate LADM, the conceptual model from UML into language of Interlis, and then use Interlis custom-made tools to derive either a Postgres database or an XML, GML, etc.
Yeah.
The advantage, let's say, of Interlis, the competitive advantage, was that it supports further semantics on the constraints in an OCL-like language, so you can check among the syntax or other constraints. But it has the disadvantage that you have to write everything by yourself in this language.
Yeah.
So where would you put this solution as an alternative solution for the implementation of LADM?
I think my first response to that would be this answer. I think the reason for me to start working with Django was not implementing the land administration domain model. That came afterwards. Yeah. I was looking for a way of quickly implementing a web application. Now, my web application mostly have to do with land administration or urban planning. So then I decided, let's take the land administration domain model from, in my case, 10 years ago, and try that. But so where would I place it? I would use it to generate my applications for clients, for the countries that I work in. So you asked where, so I would, yeah. This is one of the answers to your question, where. I don't know if that's where you're heading at with the where element in your question, but I would use it in my projects to quickly set up something, generate it, and then through iterations change it. Another second response would be, I would actually, I don't know if I made it clear in my recommendations in the presentation, but one of my recommendations for LADM II would be to have this implementation. So you make your land administration 2 model. So it's LADM 1 with the changes. There are new domains being added, I understood, and more classes. I would not just put the model in the standard, in the ISO standard, but I would extend the examples that are in Annex C. Maybe also look at the compliance or conformance annex, but I would also offer evidence of implementation through something like this.
This is exactly, Peter and Peter more, of course, in the position to answer, but this is exactly what part 6 of LADM edition 2 wants to do. So to provide the framework for implementation, not only one, but alternative solutions. That is why trying to elaborate more on your solution to understand how this solution, where the solution will fit better, for example. You say, for example, not in 3D, okay?
Yeah. No, I would. I mean, you have to realize that it's a choice for Postgres, for Django, and some other elements, and that choice can always be argued as there are better tools or something like that. But I think in this case we are talking about fully open source tools, so it's available to everyone. It's fairly simple to set up, really. I think. And maybe in the next weeks or the next months, if and when we are going to do some more on it, that element of it, the first question of Peter, should be Peter Aukers, I mean, should be demonstrated. Go to GitHub, download the stuff, and say Docker run or some command, and it will go up and running. But I know.
Jan, I do feel the example you show, the encoding of LADM in Django, GeoDjango, looks to me still very platform independent. You say, okay, Postgres, but maybe it could also be done stored in Oracle.
Yes,
say, okay,
no, that's true. Oracle or MySQL, or but I use Postgres. that's but it's not limited to that.
Yeah, where is that in your code here that you have Postgres or QGIS and not S3 or Oracle? Is there anything which is platform specific?
I think you tell it somewhere here that it's instead of SQLite, it is a database somewhere here. So you tell it here to implement it in a database. So if it's Oracle, it's something like this. Can't see the. No, I think somewhere it's overwritten somewhere else. But it starts off with SQLite 3, and then I make it happen in Postgres. But there are other databases. So Django is not hooked on Postgres. It's could be anything.
And where's the front end stuff? Say QGIS or S3 or the web, the GUI.
I think you're getting now into areas which are also fairly new to me. But there is a. I think this is the web link, and then Nginx.
Jan,
you're getting
what you presented, and I think this is exactly what we need in the future of the LADM part 6, as FTGIS said.
Peter, can I say something?
Yeah, please, it's your time.
I'm sorry, Jan. My next meeting is at 2 o'clock, so thank you very much for this. Somebody is phoning me now. Thank you very much for this presentation. Really, this is fantastic, and I think you discussed it already a little bit with Peter, that we are organizing a 3D land administration and LADM workshop during the next FRG event in Amsterdam. I have the template available, and I would be very happy to include you in the program. And I would also like to invite you to publish this. Sorry, somebody is phoning me. To publish this, because your presentation is almost like a paper. You have to add a few words, and you have a very nice paper that can be shared to the world. Because I think this is really very, very useful. And during this workshop, the issue is, of course, interoperability. Now we have LADM implemented in different environments. Django is maybe one of them. So what does this mean now for interoperability with implementations developed in other environments? So that will be maybe not the discussion now, but could be, I think, an important subject to this workshop. I would be very happy if you could join, Jan. And thank you very much.
I think I'm happy to. It's even though it's a long time ago, it's still a topic and a subject that interests me. So, Grit is already gone. Oh no, there he is. Oh, you move in my screen. You move, so I thought you logged out because it's almost 2. No, I'm happy to, Grit. That's fine.
Yeah, thank you. So you will find an invitation. We will be in touch on this. Excellent. And by the way, this is an invitation to all the participants in this workshop. You have to be there during the workshop that we organized during the FLG